Let's take a look at section 2.3, solving radical equations graphically. So we're going to do a little bit of a review from 20-1 first. There's a lot of connection between 20-1 and 30-1. First of all, what is an extraneous root? Well, that's a solution that you get algebraically, but that doesn't actually exist if we look at it graphically. And if you do left side equals right side, you'll find that your answer doesn't work there either. Now, what is that caused by? Well, generally it's caused by squaring. So if we take an example of a left side equals right side situation. Normally when we're graphing, we're looking for where the left side equals the right side or where we have an intersection point. So maybe we have two graphs that look something like that. There's clearly only one place they're going to intersect. But if I was to actually go and square both the left side and the right side, my graphs might look something like this. So the blue one becomes a parabola, and the red one also becomes a parabola. Well, now I've just introduced a second solution. So if I was to go determine this algebraically, I would come up with two solutions. One of those must not be correct, so you have to verify the original equation graphically or using left side equals right side. Now taking another little step back to 2.2, we already talked about this. What is the domain and range of y equals square root of x, and why? Well, we can't square root of negative, so x must be greater than or equal to 0. That's our domain or range. That's our domain. The range is y also has to be greater than or equal to 0. But why am I bringing this up again? Well, what about cube roots? Well, the easiest way to prove what the domain and range of a cube root is to actually go, well, -2 times -2 times -2, what's -8? So by multiplying a number by itself 3 times, I'm actually able to get a negative radicand. So that means when I have a cube root, the domain actually is just real numbers. And that's going to be the same for our range. So y is also a real number. Now anytime we have an odd exponent, or odd root, that's going to be the same generalization. We're going to be able to have any x value, any y value. Anytime we have an even root, you're going to have some type of restriction on the radicand, where it must be greater than or equal to 0. So algebraically determine the roots of the equation square root of x plus 2 minus 4 equals 0. State MPVs. Now MPVs are non-permissible values, values that we cannot have x being. So here, x plus 2, we cannot have x plus 2 being less than 0. It can be 0, but it can't be less than 0. So I'm going to subtract 2 off both sides, and I get x is -2. So therefore, my MPVs are x is less than -2. Okay, now we need to solve this. Well, I'm going to add 4 to both sides because I need to isolate that radical. Then I'm going to square both sides. So I get x plus 2, and I get 16. Subtract 2 from both sides, and I get 14. Now it says to verify graphically. I'll let you do that. I'm going to just show you how to do it algebraically using left side equals right side. So I'm going to substitute 14 for x. So 14 plus 2. So we get 16. There's a -4 there. So 4 minus 4 is 0. Perfect, because the right side already started off as 0. Now we should explicitly say then, therefore, left side equals right side, and then restate what our answer is based off that conclusion. So x is equal to 14. One last question from Math 20-1. There's a little extra step to this one. So again, determine the roots of the equation, state the MPVs. So my MPVs are going to all come from this radicand. So again, 6 minus x has to be cannot be less than 0. So I'm going to add x to both sides. So I have x is greater than 6. So x cannot be greater than 6. So our MPVs are x is greater than 6. Okay, step 1 done. Step 2, the radical is already isolated for us. So I'm going to square both sides. Now, when I do that, I got to make sure I actually do FOIL to this. I can't just distribute the square. And this is a perfect square. So it's going to be 4 squared, which is 16. And then 4 times x is 4x, and then we double that. So it's -8x, because of that minus sign there. and negative x times negative x is x squared. On the right side, we have 6 minus x left over. I need to move everything to one side, so it's equal to 0. So I'll put x squared first. Then I need to add x to both sides. So then I'm going to get minus 7x. And then I'm going to subtract 6 off both sides. So I get plus 10 equals 0. Well, we need to factor this. So this is a PSA, so product, sum, answer. A product of 10, a sum of negative 7. Well, two numbers are negative 2 and negative 5. So therefore I get x minus 2 and x minus 5. From that, I can see that x is equal to 2 and 5. And therefore. Now it says to verify graphically. Again, I'm going to do it algebraically. I'll let you do it graphically. So the first one I'll do is x equals 2. So my left side then is 4 minus 2, which is equal to 2. Our right side is the square root of 6 minus 2. So we get square root of 4, which is also 2. Perfect. So then we can say, hey, therefore, left side equals right side. Now we have one more to do. So x equals 5. So my left side is equal to 4 minus 5. And I already see a problem here. I got negative 1. But if I look at my right side, it's a root. It's a radical. Well, 6, no matter what I do to this, I'm never going to end up with a negative number here. So 6 minus 5 is going to be 1, which is 1. Well, no, those aren't the same. So therefore, left side is not equal to right side. Now I should restate my answer. X is actually equal to 2 then.